team former with over 42 years of wide experience in industry at a senior management level like managing director and general manager. After working for 32 years with various leading
42
companies,
years.
yes, after working for 42 years with various leading companies handling multi-location plant with 300 plus productive machines and MNCs, he started his own project consultancy at Pune. During last 10 years, executed more than 25 projects in India, Kenya, Tanzania, Nigeria, South Africa, Kuwait, etc. Currently, is working on prestigious project of recycling various post-consumer plastics at 100 TPH rating at Oman, retrofitting existing IC engine powered city bus with electric kit for startup base in Pune, retrofitting existing IC engine powered auto rickshaw with electric kit for startup base in Pune. Mr. Sarolkar was nominated member of Kenya Bureau of Standards Technical Committee on Plastics and Rubber for making the national standards. By virtue of a job profile, he is having expertise on mechanical system, hydraulic system, pneumatic system, electric systems, material handling, shop floor management, preventive maintenance, quality assurance, LP power generation, LV power generation, transmission and distribution, etc. He owns 8 intellectual properties. He have developed many plastic components as a substitute for metal, mainly for automobile industry, and is an authorized vendor of Tata Motors. He executed successfully strategic alliance of a Pune-based company with European manufacturer for electric vehicle and retrofitting business. He is involved in techno-commercial discussions, which is in process for strategic alliance and technology transfer for lithium-ion battery manufacturing project and EV charging station for Pune-based existing business with European manufacturer. He is having expertise on electric vehicle kit retrofitting as well on component sourcing and manufacturing. Now, without wasting much time, I would like to hand over the session to Mr. Saravakar, sir. Over to you, sir.
Thank you, sir. And good afternoon, everybody. The subject EV design is a very vast subject and requires in-depth study of various systems involved, as it is a matter of safety of individual traveling in it. We will try to cover the basic requirements in a limited time allotted to us. When we are talking of EV, everybody is talking of EV. So why we talk of EV, and is EV the only answer to the major issues like environment and climate change, noise pollution, etc., that we need to understand? Strategically, EV could reduce about 37% CO2 emission, and EV could help in grid stability by higher power demand and lower energy consumption in totality, close to 64% by year 2030. The fuel bill of about $60 billion a year can be saved by EV. EV mobility has an impact in a lot of areas, which we will discuss here now. The impact of EV is having in technology, environment, society, economy, and policies. The environmental impact is mainly the reduction in tailpipe emission, reduction in noise and heat generation, and awareness of consumption of raw materials. The technological impact is going to be increase in the efficiency, technical advantage of electric motor compared with IC engine, high voltage stability, as majority of the vehicles will be using high voltage system, The cars are using between 96 volt to 400 volts, whereas commercial vehicles, mainly city bus, is using about 600 to 900 volt system. A whole new safety requirement and trained personnel to handle the high voltage system is a major challenge. Development of charging infrastructure and additional load on the grid for fast charging station is also an important point. When we talk of impact on the society, increase in the demand, increase in the acceptance, increase urbanization, and growing mobility are the impact on the society. When we talk of economy, very high foreign exchange bills for oil imports are going to reduce drastically. Desire to minimize the dependence on oil exporting countries and infrastructure requirement to supply energy for charging station are the impact. If we talk of policy, the international specification for emission limits, a very good example for this, we can see the moving of BS standard 6 from BS 4 earlier. Development plans and subsidies for transformation like FAME 2 is also a policy affected by this. This indicates that the development of electric vehicle will have a very high impact on overall business environment and will be pushing us towards the sustainable solution. We are talking of electric vehicles nowadays, and India and overseas, everywhere we talk of electric. So why the electric vehicles have become such an important subject? Electric drive vehicles have been identified as one of the promising technology of the future due to the advantages like no tailpipe emission, no noise, no vibration, low in operating cost. Electric drive vehicles includes plug-in vehicle, plug-in hybrid vehicle, battery operated vehicle, and fuel cells. One of the important challenge in the advancement of the electric drive vehicle is to develop a control strategy which meets the power requirement of the vehicle. The control strategy is basically an algorithm designed to command the battery and the engine of the vehicle for a specific power demand. In case of battery operated vehicle, the engine is considered as an electric motor. Automobile industry in India accounts for approximately 7% of country's GDP, and aggregate total of over 30 million vehicles is estimated for 2021 production in the country. Extremely high foreign exchange bill for oil imports, environmental concerns, and government commitment for reducing carbon footprint is compelling India to shift to electric vehicle. E-mobility is the future and the most promising solution. Committing to the Paris Agreement, India has announced a major transformation to electric vehicles by 2030. Government vision to see 6 million vehicles, including electric and hybrid vehicles on road by 2020 was there. But due to the present conditions, the figure will not be achievable. Government is taking a lot of initiative and programs like FAME to push the electric vehicle. The automobile industry is basically divided into three main segments like two-wheeler, three-wheeler, passenger cars, commercial vehicle, and tractors. There are about 15 passenger vehicle manufacturer, 13 two-wheeler vehicle manufacturer, 7 three-wheeler manufacturers, 12 commercial vehicle manufacturers, and 17 tractor manufacturers in India. They have different plants at different locations. The total number of manufacturing plants and the manufacturer is listed here in a table, which you can refer afterwards. The production of automobile is increased at a CAGR of 4% between the year 2012 to 2017. The industry accounts for 7.1% GDP of the country. Indian automobile industry has a strong export growth potential in near future. As per the estimates, the total vehicle production figure by 2021 is over 30 million vehicles, which may have a slight downward trend due to the current pandemic situation. The estimates were like 24.4 million two-wheelers, 4.6 million passenger cars, 0.8 million commercial vehicles, and 0.78 million three-wheelers. The geographic presence of passenger vehicles OEM manufacturers in India is divided into mainly 3 areas. We have seen the requirement and expectation of vehicles in near future. So now we move to understand the basics of e-mobility. Electric vehicle has been the topic of discussion on local as well as international forums. So what is the difference between electric vehicle and the conventional IC engine vehicle? As indicated by the name, the IC engine is replaced with electric motor and the fuel. The fuel is a battery, which is basically a rechargeable battery. The main component of electric vehicles are high voltage battery with control system and charging system, high efficiency, high torque electric motor with controller and cooling system, transmission system, braking system, and high voltage air conditioning system. Basically, the battery cost in India is very high, and the overall cost of the vehicle is almost double compared to the IC engine vehicle. In order to overcome this hurdle and increase the speed of transformation, the government formulated EV policy and inducted Niti Aayog in the system. Niti Aayog, in association with other government agencies like Ministry of Heavy Industry and Public Enterprises, Ministry of Power and Renewable Energy, Ministry of Urban Development, Ministry of Finance, Ministry of Roads and National and Highways, and Department of Science and Technology is working for achieving the transformation figures. As per the plan, government is targeting to introduce about 6 million electric vehicles in country by 2020, which seems to be difficult in the present condition. The plan was to introduce about 400 passenger cars and thereby saving 120 million barrels of oil and 4 million tons of carbon dioxide. The investment required for this change was estimated at rupees 20,000 crore plus, which amounts to approximately $3 billion. The planned approach for mobility transformation involves basically 3 stages. One is system integration, shared infrastructure development, and scaled manufacturing. Government is firm on bringing down the carbon footprint in Indian mobility by 2030, and EV seems to be pivotal in the mission. Public transport like city bus and fleet cars and 2- and 3-wheelers are the first movers towards EV in India. Government has announced a policy decision that the production of IC engine 3-wheelers will be stopped from the year 2024. In order to show the commitment, A phased replacement of city buses and state transport buses with EV is already initiated and it is picking up the speed now. For your information, just last week in Mumbai, 300 EV buses are started. EV buses are already running in Jammu, Chandigarh, and Uttar Pradesh. The EV movement in India was started basically by REVA at 2001. However, basically due to the very high cost and lack of infrastructure in charging, it did not pick up the speed. The total number of EV in India by the year 2017 was merely at 7,100 as indicated here. Society of Automobile Manufacturers have predicted by 2026 the sales of EV in India based on 5.8% GDP will be very high. The production figure, median figures I am talking, is passenger vehicles approximately 6.27 million, passenger vehicle commercial or the fleet 5.13 million, commercial vehicle good 2.5 million, commercial vehicle passenger 442,000, two-wheelers a very high figure at 53.1 million, three-wheeler 1.35 million, making total vehicles at 68.8 million. If we consider even one engineer for 1,000 vehicle, you can understand the requirement of staff required or the requirement of the engineers required for this project, which is going to be very, very high. It is more than 60,000 plus, 70,000 plus. Based on this Niti Aayog plan for 2026, the conversion possibilities are reduced on passenger vehicles to 20% at 1.25 million. Passenger vehicle commercial and fleet is reduced to 60% at 3.7 million. For commercial vehicle passenger, it is reduced to 60% at 0.26 million. For two-wheeler, it is reduced to 20% at 10.6 million. For three-wheeler, it is reduced straightway by 50% to 0.67 million. And now that Niti Aayog is planning for 15.89 million vehicles. It is expected that the EV owners will charge the vehicles overnight at the home. Level 1 and level 2 charging equipment will be primary option for the home charging. Public charging stations will make EVs more convenient, help reduce the range anxiety, and increase these vehicles for the useful range. Public charging stations basically use level 2 or DC fast charging and are located in high density locations such as shopping centers, parking lots, etc. Charging equipment is classified by the maximum amount of power in kilowatt it can accept. The AC level 1 charger, which is at 240 volt alternate current, and charging rate is approximately 1.2 kilowatt. Lot of local businesses are taking interest in charging business. Majority of them are in the power electronics and battery rectifier business currently. Rechem, Deltron, Ador Power are some of important them. Currently, there are about 15 OEM supplying EV chargers, and only 3 of them are for passenger cars. Rest all of them are for two-wheeler and three-wheeler. About 6 global players are likely to enter the Indian market in the near future. They all have advantage of own design and are studying the business model and other areas for entry at a particular time. Although their products are CE certified and running satisfactory in Europe, we are of the opinion that they need the rework on the specification for local market, mainly due to the varied climatic condition. NTPC is a key player in setting up the EV chargers and infrastructure in the country. Tata Power is a private power distribution company investing into EV charging infrastructure. Tata has already installed 3 charging stations in Mumbai, planning for 50 numbers in Mumbai and New Delhi. Ola has gone a step ahead in implementing charging stations. Ola has invested over 50 crore rupees in the EV project, and about 200 cars are charged in a pilot project at Nagpur. Although these are the figure, EV charger manufacturing has not yet picked up the speed as it should have been, specifically for the passenger car and the commercial vehicles. Currently, the passenger car and city bus, if you want to have a charging station, they require a license. And that is one of the main reasons why it has not picked up the speed. By end of 2021, about 50,000 charging stations will be installed, having a total of 300,000 chargers. Out of 300,000, 240,000 is likely to be slow chargers, and 60,000 or 20% is going to be the DC fast charger. By end of 2026, about 2.5 million chargers are likely to be installed throughout the country. Currently, the battery market is led by Exide and Amara Raja industry, mainly for lead acid batteries, which is worth of 177 billion or about 80.5 million units. Automobile is a major market contributor for 60% of the battery market. Energy storage market is not yet developed in India, so we will not discuss on the energy development or energy storage market. Lithium-ion battery market is just started in India. The expected capacity by the end of year is likely to be 3 gigawatt for manufacturing. Lithium-ion battery manufacturing is covered under Atmanirbhar Bharat under 10 giga projects, and very soon we can see number of manufacturers in the battery business. EV charging specifications are designed as Bharat EV charger AC001 and DC001. The home chargers are mostly onboard chargers using single phase supply at 230 volt and a maximum of 2.5 kg rating, which requires a connector type of IEC 60309. In slow charger, the AC supply is converted to regulated DC voltage and supplied to the onboard charger, which converts AC into DC, and then the batteries are charged. In case of DC fast charger, supply DC to the battery, eliminating onboard charger. The charging rates are commonly high, up to 22 kilowatt for car like Nissan Leaf. DC charger with 50 kilowatt rating are common in overseas market. One of them is installed at New Delhi recently. DC charger with 350 kilowatt rating are also operational, mainly in the overseas market. Due to the high power rating, the operating system requires to be a high voltage system like 720 volt or 900 volt, etc. The charging system, including charging cable, need to be liquid or jelly cooled for effectively removing the heat generated during the charging. These stations can charge bus battery in about 20 minutes to 1 hour, depending on the battery rating and the discharge conditions. The similar charger is used for flash charging the supercapacitor buses, which gets charged during the time when the passengers are boarding and deboarding. In level 1 charging, in AC is converted regulated DC supply onboard charger to the battery, whereas in case of level 3 charging, DC charging, the AC supply is converted to regulated DC supply by EV charger, and DC supply is directly fed to the battery. It means in this case, the onboard charger is not coming into the picture. The charging time is directly reverse proportion to the charging current. It means if your charging rate is very high, then the charging time is very low. The charging station and the charger has a definite function, which are explained here. The charging station is having safety interlocks receiving AC grid supply, which gives output of power consumed for the billing purpose. The AC supply is converted by rectifier, which is fed to the power control unit, which supply the regulated power to the battery for charging. The battery, the BMS, the protection unit, and the power control unit all have the communication for effective and efficient working. Power electronics play an important role in charging system. In case of DC fast charging system, the three-phase grid supply between 20 kilowatt and 350 kilowatt is received at the charging station, which gives the metering information as well as convert the power received into the variable DC supply with adequate safety interlocks. The charger through protection unit supply the control current and control voltage to the battery charging. The battery, the BMS, the protection unit and charging stations are all in communication. So this is a basic block diagram for a complete charging system what we use. Right from supplying the power to the charging station to the battery. This is a basic DC fast charging station with multiple charging points. In this, it receives a grid supply which is converted into DC and supplied to multiple charging points through a controlled unit and independent DC-DC converter to charge the multiple vehicles at the same time. Currently, we do not have this type of charging stations in India. We have an individual charging station, but soon we can see this in India also. Some of the standards of DC fast charging are shown here. The ABB Terra is having a rated power of 50 kilowatt. The another 50 kilowatt is there. Tesla is having 135 kilowatt rating. Another 150 kilowatt is EVAC, and ABB Terra is 350 kilowatt. There is a possibility that ABB Terra will be installed in India very soon. There are two types of plugs which are used for this. The charging socket is specially designed type 2 on depending on the rate CCS, CHAdeMO or GBT is used. The CCS is having maximum rating of 850 volt and 200 ampere or 170 kilowatt. CHAdeMO is having a rating of 600 volt, 200 ampere or 120 kilowatt. GBT is having a rating of 750 volt, 200 amp, 50 amp and 187 kilowatt. The communication system used for these four chargers depends on both these are PLC or PWM is a the architecture of charging system installation communication must for the safe and secure charging of this EVAC and CMS communication is must for grid related parameters, user authorization, billing, etc. CMS and mobile communication is necessary for locating the nearest charging station, reserving the time slot for billing information, etc. That, huh? नहीं कल थोड़ा नहीं आला सन. Since major of the time the cars are packed at the power stored in the batteries is unutilized. During the peak power demand, the stored energy from the battery is delivered to the grid, and once the demand is low, the batteries are charged back. The system requires a very good communication between vehicle to grid. The power return to grid can save up to $4,000 per year per car. This is something similar to net metering of the solar system, and this can have a very good business in India. We had discussed about the charging types, the process and the methodology. Charging system definitely works on the standard. The standards are mentioned in this slide. Due to the lack of time, we will see this and anybody who is interested in it afterwards. When the popular impact on different areas like grid, negative impact will be voltage instability. If lot of vehicles are charged simultaneously, the voltage may get imbalance. The power demand can be increased very high, can be disturbed. There can be a voltage sag. Even a power loss can be there, and the overheating of transformer can be there. The positive impacts are facilitating the smart grid, vehicle to grid system, and integration of RES. The impact on environment is going to be less greenhouse gases generation, which is one of the very important thing. The impact on economy will be lower operating cost and chances to benefit from the vehicle to grid system. After covering the basics of EV, now we'll curious know about the future developments and the upcoming trends in EV. The major trend can be classified in the area like vehicle to as earlier the energy from the battery can be fed back to grid during demand. Batteries can be charged when the demand is low. This in grid stabilization, the power generation can manage supply situation. Battery charging technology is changing at a very fast speed. In European countries, the roads are developed with charging infrastructure and can be charged running on the road. Also, there are flash charging where the battery is topped up during very small time, like when passengers are boarding and departing. Better battery technology is also coming up. The battery is developing at a very fast speed. Charging and overhead power supply for charging are latest development. EB has associated with Ashok Land to introduce the overhead charging in the city. Power DC-DC fast charger with overhead power transmission and a precise robotic interface. The capex requirements are very high and we'll have to see this low. The metal oxide batteries are also one of the development.
Then, hello, Sarolkar sir. Wait for a while. All participants, I'll contact them. Hello, I have right now contacted sir and sir will be online again.
Hello,
Yes, sir, you are audible.
I'm audible now. Okay, so can you please tell me where exactly I got disconnected? So I'll continue from there.
Just a minute, sir.
Sir, you just share your screen so that we can tell you
Yeah,
where.
I have already shared the screen. Are you not able to see the screen?
No, sir.
Oh my God. 1 minute.
Yes, sir.
Are you able to see the screen now?
No, sir, not yet.
It's taking time, I think. Can you do one thing? Can you open up my presentation and tell me the slide number so I'll start from there? I think it is sharing now.
Yes, sir. We are sharing the PPT.
Okay, so just tell me which slide we were.
Yes, sir. Wait a minute. Yes, sir. This was the slide.
1 minute, let me see. So major trends. So 1 minute. What is this? See, as we said, the vehicle to grid, the battery charging technology, the better battery technology, wireless power transmission, and overhead power supply. These are one of the trends which are coming in the market very recently. As discussed, vehicle to grid is a energy in vehicle to grid system. The energy stored in the batteries is not utilized when the vehicles are parked. So when the vehicles are parked and when there is a high demand, the energy stored in battery can be fed back to the grid during the peak demand, and the batteries can be charged when the demand is low. This helps in grid stabilization as well as the lower power generation can manage the power supply situation. This is a major trend in European market, and in general a vehicle owner can save about 4,000 US dollar per car per year. The battery charging technologies are also changing very fast. The battery charging technology like LFP4, metal oxide batteries, now the nuclear batteries are coming up, and the trend is to see that the batteries are charged at a faster speed, first thing, and the batteries will have a long range. The metal oxide batteries which are currently being developed is having a range of about 1,000 kilometer for a car like Maruti Swift, and a replacement cost is hardly 350 rupees. So the running cost per kilometer is 35 paisa. The better battery technologies are also getting developed. The nuclear batteries are coming up, which is probably going to be a lifetime battery. LG and Tesla are working on a battery with million mile, means you need not to replace the battery throughout the life of the vehicle. The wireless charging is also getting popular everywhere in the European world. It will take long time for us to see that development in India. The overhead power supply is again a latest trend, wherein the ABB has basically developed the technology, and it is currently used for charging the bus. When the passengers are boarding or deboarding, the batteries are getting charged. Hope you are able to hear me. Can we go to the next slide? Hello?
Yes, sir.
Can we go to the next slide? Because my slide control is, I think, not working here.
Yes, sir. Yes.
Some of the latest trends are range anxiety, which is likely to end because the vehicles with 500 kilometer range are already on the road. It is expected that by 2040, about 33% of global car fleet and 54% of new cars will be electrical car. Developing autonomous vehicle is another development which will be commercialized in the near future. In order to bring down the cost of the EV, the OEMs are working on powertrain and energy storage system. And power electronics is playing major role in optimizing the weight, efficiency versus performance versus cost of the vehicle. So that is also one of the very important area. Please go to the next slide. The OEMs have planned to launch over 100 new battery electric vehicles by 2024. The new development of vehicle architecture around EV concept gives more flexibility and scope for cost optimization. Please, next slide. This slide shows the concept of native architecture. In native architecture, you have a lot of flexibility and the batteries can be stored in one place. And it can have a possibility of having front vehicle drive, rear vehicle drive, front drive vehicle, rear drive vehicle, or all four-wheel drive vehicle with the same chassis. If we are working on the existing IC engine and we are retrofitting the electric components in the bus, in the vehicle, then the battery pack need to be distributed in different areas, and the wiring harness and other requirements are going up, which not only increase the costing, but increase the complexity also. Next slide, please. The EV powertrain development and the integration trend has shown its positive impact on reduction of the weight and number of parts, which directly affect the costing. You can see the numbers here earlier and the number in the next one. The gray one is showing the original design and the blue one is showing the current one, where the number of parts are reduced from 14 to 4 and the weight is reduced from 10 to 5. So basically, they are working on and reducing the weight and the cost, everything. This is helping bring down the cost of the EV. Next slide, please. Automobile manufacturers are forced to give a lot of add-on to the vehicle, which ultimately gives the improved driving comfort, the use of artificial intelligence and IoT increasing day by day, the enhanced user interface, the infotainment system, wide range of interior functions, and smartphone interface are the development that are the latest trends in the vehicle. So you can see the automobile is revolving towards IoT and is getting more and more smart nowadays. Next slide, please. Now, in order to see the trend in the charging, we will see this a small video here. As I told you, the vehicles will be charged when they are running. There is an audio to it also. You can switch on the audio. Please on the audio for video. I think it is muted.
Yes, sir.
The heavy and expensive battery with a limited driving range and a Meet Electrion and its unique technology developed in order to change the future of transportation. The change starts today. Electrion Smart Road quickly and efficiently transforms our public infrastructure into a source of advanced energy. Public transportation vehicles will not require any refueling or charging at any time whatsoever. So what does Electrion do? Electric vehicles will receive continuous power while the vehicle is being driven directly from the infrastructure embedded under the asphalt road. Instead of carrying the heavy and expensive battery with a limited driving range and a short lifetime, with Electrion's groundbreaking technology, one can simply travel non-stop. Our city's landscape will change dramatically. No more gas stations, nor cumbersome battery charging stations. And as the number of vehicles traveling on the smart road increases, air pollution around us will decrease drastically. Electrion's innovative and sophisticated technology is extremely efficient and very affordable. The upgrading of a mile of an asphalt road will only require the embedding of a narrow copper coil, which will be connected to the electricity grid. And that's it. We completed another smart and green road in just a few days. The upgrading of vehicles is also very simple. We install a receiver at the bottom of the vehicle and we are ready to go. Electrion's plan is underway. We are moving fast on the road to turning entire cities into electric and green cities. After we successfully complete the demos, we are embarking on pilot projects all over the world together with our international partners. We shall start electrifying main routes for public transportation. The next stage will enable us to continue the upgrading of the main roads of cities. And from there, we shall open and service distribution vehicles, sharing vehicles, and finally, autonomous vehicles. In order to ensure maximum flexibility, the vehicles will also be able to travel on non-electrified routes. The future of transportation is already here. The technology exists and works successfully, changing the reality as we know it. You are invited to join us and follow the pilots in the first deployment on Electrion's website. Come on, let's go for a ride.
Now we have discussed all others, so we move to the EV design. EV design is a very complex subject. However, we will try to have the bird's eye view on the subject and understand the basics of the EV design in a limited time frame available. EV design main steps are finalizing the technical specification of EV, like power required, battery capacity, top speed requirement, and the acceleration requirement. Once the specifications are finalized, the next step is to decide on the subsystems and the specification for the subsystems. In the third stage, the component specifications are finalized. While doing this, design to cost considerations are of very high importance. The time frame for development and budgetary allocation also play an important role in design. Because if you design a very beautiful system and if it is not affordable or if it is not acceptable in the market, then it is of no use. So it has to be cost effective. It has to be done in a stipulated time frame, and it has to match to the specifications whatever you have planned. Next slide, please. While designing the electric vehicle or component, there are a lot of considerations like gross weight of the vehicle, diameter of the tire, energy required to move the standing vehicles, maximum speed required, acceleration time required, the range required, charging and discharging requirements, etc. And all these points need to be considered in a designing. Next slide, please. The designing as a whole needs a detailed study of requirements, understanding the harsh working conditions, communication and integration of different subsystems. While designing, cost considerations are of very high importance, specifically in India, as the market is cost sensitive. One has to keep the balance in quality, cost and time to commercialize the design. The market specifically for EV and its components was solely depending on the imports, mainly from China till recent, mainly due to the cost considerations. No effort was done for R&D and for local development, as the components from China were coming at a very attractive price. The initial EV supplied by both the manufacturers in India was by the way of value addition in CKD components. Now the movement for local development has started. However, to the best of my knowledge, it will take a longer time to pick up the speed. There is a possibility that during the time, other OEMs which are waiting and watching for the situation may jump in. So the lack of manufacturing and lack of R&D activity is responsible for not picking the speed. That's what I can say. Next slide, please. In order to explain the criticality in the design of a sub-assembly or the component of EV, we need a detailed study of requirements, finalizing the specification and to design a component or sub-assembly to give the required performance. Now here we take an example of the battery and see the design considerations required for battery. While designing a battery, one has to consider about 45 to 50 points as listed in the presentation. Now these points are very basic points, but they are very important also. And in battery designing, the points are like the end use of the battery pack, where you are using the battery. Hello. Hello.
Sir, just a minute.
Yeah, so the end use of the battery, whether you are battery using this battery for vehicle or for fresh. Hope I am audible. Hello.
Yes, sir, you are
Hello.
audible.
Okay. So we again start from the battery designing. When we are designing battery, we need to consider about the 50 points. We will discuss these points here. The first and very important is end use of the battery, where we are using the battery, whether it is for application of a vehicle or for a storage. The requirement for storage battery and the requirement of traction battery or the electric vehicle battery are totally different. Then the cell type, which cell chemistry we are using, whether it is lithium ion battery, whether it is NMC, whether it is LTO battery or something else. The cell type will directly decide on the charging time, the performance of the battery, the range of the battery, etc., etc. Then what is the battery system design energy? What is the usable energy of the battery? What type of battery system we are using? What is the voltage and what is the current rating of the battery? Then what type of charging power we need for charging the battery, continuous power and the peak power. Similarly, what is the discharge requirement on a continuous basis and on a peak power? That also will decide the type of cell what we have to use. What are the self discharge rate? Again, it will govern the cell requirement, the combination of the battery, etc. The overcharge and the over discharge conditions that are very important, and that will change the type of the cell what we are using. The life expectancy of the battery, how many cycles or how many years the battery should last, that is again an important criteria. Then what is the motor peak power? Your motor peak power will definitely proportional to the battery power. Higher the motor power, higher the battery power. Then what is the voltage, working voltage of the system? Whether you want 48 volt, whether you want 96 volt, or you have 600 volt system. So basically in this, the number of cells you will connect in a series to get the required voltage, and a pack of number of cells, which is considered as a module. You can assemble number of modules to get the required ampere hour. Next slide. The nominal voltage we just discussed. For a operating system, whatever voltage we require, we have to have the voltage accordingly. The cell module, the individual module will have a particular ampere hour rating, and this rating again depends on the type of cell we are using. The module quantity, how much modules we have to connect, that will decide on the total power of the battery. If we connect 10 module or 20 module or 50 module, it all depends on the type of module and the type of cells what you are using in the module. The number of modules when we coupled together, it forms a complete battery, and that will decide the battery capacity. So that is considered as a pack capacity. Now, battery pack voltage connections. When we talk of high voltage battery, we need to have two type of connections on the battery. One is the high voltage and one is the low voltage. The high voltage connection is used for motor and the transmission system, whereas low voltage connection will be basically used for the controls for LCD and trafficator and headlight, etc. Usage of environmental conditions. What is the charging rate you require? What is the discharging rate you require? What are the temperatures and humidity it can withstand, etc. need to be considered when we are designing a battery. The heating requirements, whether you need to have the heating on the battery. Basically in India we don't need it, but in India, in some of the areas, like if we go to northern area, Jammu and Leh and Ladakh, there sometimes we may need the heating because the temperatures are going to 0 or even sub-zero. So whether you need a heating requirement, that is another consideration when we are designing a battery. And what type of heating we are using, whether it is a resistive heating or whether it is a fluid heating. The cooling requirements. Cooling, yes, it is a very, very important consideration because when you are using a system, a lot of heat is generated in battery itself. When the temperature of the battery is going up, the battery performance is getting deteriorated. And the high performance batteries are recommended to charge, discharge, and operate at a particular temperature. So like we have a cooling system for the engine in conventional vehicle, we have a cooling circuit dedicated for battery. This cooling can be shared with the motor also, or it can be a separate one also. So what type of cooling you are using, whether it is a air cooled or whether it is a liquid cooled, that plays an important role. The air cooling is generally used for a very low capacity batteries, and if your battery rating is going more than 10 or 20 kilowatt, liquid cooling is recommended. Coolant circulation is again a very important because coolant can carry a particular amount of heat from the vehicle at a time. So the flow of the coolant in liters per minute is very, very important consideration. The coolant connector preference is again important because there are particular type of coolant connectors which are recommended, which will have a safety also, built-in safety, and it will allow a particular flow. When we are talking of a flow, the pressure also is required, and the coolant pressure and the flow both are maintained with a separate coolant pump. The type of coolant we use also considered, or also it is important to effectively remove the heat. Most of the time the glycol based coolants are used, which can operate even at a lower temperature. The battery required communication between battery and BMS, battery and vehicle controller, and other systems. So what type of diagnostic tools or what type of connectors you are using, that is also important. Next slide, please. The number of CAN channels you require, whether you are using CAN protocol or something else, that also you need to consider when you are designing a battery. The charging C rate, the charging rating in the kilowatt, these are again important. The higher the C rate, the faster the charging. The higher the kilowatt rating, the faster the charging. whether there are regenerative requirements. That also we need to consider when we are designing a battery, because there are special type of switches used when we are using a regenerative battery. The charging pattern, whether we are using charging and discharging simultaneously or not, that also is one of the important thing. In general, we are not using it simultaneously. The communication interface, what we are using, the communication protocol, what we are using, the data required for monitoring, like remaining time of the battery, if there is any battery error, what is the voltage, what is the temperature, what is the current drawn by the battery, all these things required to monitor, and the data required for this monitoring, what type of data you need to take, that you have to decide when you are deciding when you are designing the battery itself. The charger communication protocol is very important. Without that, the battery system will not work. Whether you have onboard charger or you don't have onboard charger, that will decide on the battery charging system. The connector specification, what you are using for charging the battery, again governs the battery designing. Next slide, please. Where you are locating the battery is a important decision. We have to consider, we have to see that the batteries are not installed in the close proximity of a heat generating source. If you install the battery near the heat generating source, the battery temperatures is likely to go up. So the location of the battery is again a very, very important thing. The design verification and the testing requirement of the battery is again an important area when we are designing a battery. But most of the batteries what we buy commercially, they already have taken care of this. Then when we are designing a battery, we need to see the prototype development time, whether we have to design this battery within 1 month or 1 year. That is very important. Finally, the packaging requirement and the transportation compliance. What type of packaging we need, what type of transportation you are going to have, what type of load it will have. In case of accident, if the battery fell down, then the battery should not burst, the battery should not catch fire. So all these things need to be considered when we are designing a battery. So all things, when in totality are considered, we get a product. And when we are doing this product development, we have to consider the time factor and the cost, which is again a very, very important. Thank you. I think I have covered majority of the topics and a basic presentation. This is basically a BMS and its communication with the other subsystem. It is shown a vehicle control unit, the motor control unit, onboard charger, offboard charger is shown on the top. The blue box is basically the battery, which is having a number of batteries, and battery management unit number 1, unit number 2, like this you can have, and a number of batteries are connected there, and it is showing a basic communication between BMS and other subsystems. Yeah, the next one, please. This is a basically schematics of prismatic cell module assembly and the battery assembly. The different cells are packed together to form a battery, a bus bar, a top cover, a flexible PCB, the end compression plates, the side plates, and the battery terminals are shown here. Next slide. This is basically a pouch cell battery. How this pouch cell battery is assembled is shown in this. And again, Same thing, the bus bar, the connection, the end plates, etc. are shown here to give the basic idea of a battery pack. On the left hand side here on the bottom, we can see a complete battery pack, and the right hand side is a distributed model of the battery. Thank you.
Yes, participants, if you have any questions, you can unmute and you can ask, or otherwise you can mention in the chat box also. Sir, will you please